So, welcome to one of the two parallel Java 8 sessions. My name is Delabassee. I work at Oracle. I'm based in Belgium, but I do report to HQ. So basically, I work for the organization that is responsible for different projects such as Glassfish, Jersey. We are also responsible for technology, Java EE, Java IC, and then we also have a bunch of other stuff that we are working on. So, and that's me a few months ago on stage at JFocus, and someone in the audience said that it's not a real conference unless you read Oracle's safe harbor statement at least once. So please enjoy. So, joke aside, I will talk about Java 8. Most of the work is done, but it's not fully finalized. And at the end of the day, it's really the different experts from the GCP who have the final say on all of this. So some of the things that I will talk about today might still evolve a little bit. So the current version of the Java specification is Java 7. It was finalized quite some time ago. So we started at that time to think about what we should do next for Java EE8. It took a bit of time, but nevertheless, we are here to talk about Java EE8. So today I will give you a quick overview of some of the new capabilities that we are adding to the Java EE platform. So the first API that I want to talk about is JAX-RS 2.1. At the beginning, the JAX-RS expert group wanted to do three things in JAX-RS 2.1, but they had to drop one. That is a non-blocking I/O support in the different provider of JAX-RS. They had to do that because they started to prototype some of those API to do that, and it turns out that they need the Flow API from Java SE 9. And as you know, Java SE 9 will hopefully be released shortly. But nevertheless, Java EE8 is based on SE 8. So that means that we have to use what's inside of Java SE 8. So the two big capabilities of JAX-RS 2.1 are a new reactive client API and support for server-sent event. So let's look a little bit at what we have in JAX-RS 2 in terms of client API. That was one of the big deals of JAX-RS 2. So we basically have a standard API that you can use to consume REST endpoint. The idea is that JAX-RS will provide you a client-side container that you can use to easily do those requests. So how it works? Well, you first need to have an instance of that client container. Then you basically have first to set the web target, so that is basically the resource, the location of the endpoint that you want to reach out. Based on that target, you have to construct the request. And finally, based on the request, you will actually invoke the request. So that means that you will get a response from the remote endpoint. And you see that, for example, in this very basic example, what I expect to get back from my REST invocation is of type string. So that's what I get here. So that client container is really doing all the heavy lifting for you. So that also means that once you are done, it's a relatively heavy object. So you need to make sure that you close that object. So that is JAX-RS 2. The JAX-RS client API is fairly rich. So that means that, well, you can basically easily construct any type of request. You can set the SSL context, those kind of stuff. So that's not new. That is JAX-RS 2. The thing that is not clear here is that it's a blocking request. So it's an asynchronous invocation. So as soon as I do a GET, basically my call will be blocked until I get the response back from the server. So that is the standard behavior. Luckily for us, in JAX-RS 2, we also have an asynchronous behavior. So to basically turn a blocking request into an async request, we just have to use an asynchronous invoker. So that's what I do using that async method invocation. So it's basically just to tell to the client-side container that I want to do this request in an asynchronous fashion. And you see that what I expect to get back is of string type, but what I actually get back is a future of string type. So that means that basically my code will not block. But obviously, at some point in time, I will have to use that future object to actually get the result from the invocation. And typically, how you do that, you are basically blocking on the future object to get the result. So yes, it's asynchronous, it's non-blocking, but you will have at some point in time to block. So it's a bit annoying. Luckily for us, we have in JAX-RS 2 an invocation callback. So we have the ability to basically set callback that will be invoked when we have the result or when something goes wrong. So it works like this. So we have to use the async invoker, and then we specify, we pass it an instance of our invocation callback. It has two methods, the completed method that will deal with the result once it has been sent by the remote endpoint, and the fail method, the one that will be invoked if something goes wrong. So that basically solves the issue when you want to do asynchronous invocation, but you don't want to block on the future object that you would get in return. Now, let's use that API with a very basic microservices scenario. So it's basically one travel agency services that has to use 4 backend services through REST. So the idea of that scenario is very simple. So we have a user that comes into the travel agency services, and then based on that user, the services will have to first go to the customer services to get the travel history of that user. Then, based on that history, it will invoke the destination services. So we would like to suggest some potential destination to that user. And for all the destinations that we're about to suggest, we will also invoke the weather services and the quoting services, because we want to include some weather information, and obviously we also want to give a price to that user. Obviously, we are not going to do that in a synchronous fashion. So if we want to scale, we have to do that in an asynchronous fashion. So how it would work? Well, first, I have 4 backend services. So let's just simplify that and pretend that I just have 2 backend services. So I have to do that in an asynchronous fashion. So I have to use the async invoker to do my first request. So the first request is basically to get a list of potential destinations, so some recommended destination. So I have to specify an invocation callback for that specific async request. That invocation callback needs to have 2 callbacks. The first one is the completed callback, so the one that will be invoked when we have the result, so when we have the potential destination. So in that callback, what we will do another request. So we will basically we will have all the destinations that we are about to suggest. And for all of those, we will do an async request to get the forecast for all those destinations. So we want to do that in an async fashion as well. So that basically means that we have to specify another invocation callback with the 2 callbacks, and so on and so on. So I guess you see that where I want to go. So clearly that async API of JAX-RS 2 works if you don't have dependency between the services that you need to invoke. But as soon as you have some dependency between those services, you will be able to do it, but the code will be very difficult to write and maintain, and obviously debug. So that's basically what we are solving in JAX-RS 2.1 with this new reactive invoker. So in JAX-RS 2.1, we have this new RX invoker. And you see that the return type, when we are using that invoker, is of type completion stage. So we don't have a future of response, but we have a future of the response type that we expect to get. So that basically means that now we can do things like this. So I can do a first request. I'm using the new RX invoker. I have in return a completion stage of type number. I can do another request. Again, it's an asynchronous request, but using this reactive invoker. And then it's just a matter of using the completion stage API of Java SCA to basically define the workflow between those different invocations. So those 2 requests are done in an async fashion, so they are not blocking. And in this case, I'm using the then combine. So that basically means that they will be done in parallel, and at the end, the result will be combined and passed to that B consumer, which is reserved if affordable. So some kind of business method that will do something with those results. So that is part of JAX-RS 2.1. That new RX invoker really helps when you have to write when you have to consume services that have dependency between them. Another feature that is added to JAX-RS 2.1 is support for SSE. I guess you know what SSE is about, so it basically provides a standard mean for a server to push in an async fashion payload to a connected client. So the client establishes the connection, and as soon as we have the connection, the server can basically push at any time some kind of payload over HTTP. That is something that is widely used, so that's something that we're adding in JAX-RS 2.1 on both sides, so that means on the server side but also on the client side. So JAX-RS 2.1, we're adding a few interfaces to do that. So we have this super interface SSE event, which is basically some SSE event. And it's extended by two interfaces, one on the client side and one on the server side. So we have outbound SSE event, which is the server-side view of an event. And we have the corresponding inbound SSE event, which is the client-side view of that event. So the thing that is important to keep in mind is that SSE is one way only. So it's the client establishes the connection, but then it's only the server that has the ability to push, so from the server to the client. So that means that you will create the event on the server side, but on the client side, you will just consume those events. Then we have this new SSE event sync, which is basically just a connection between a server, so an SSE endpoint and a SSE client endpoint. So how it works? So this is the server-side view. So this is basically an SSE server endpoint. The thing that we have to do, we have to inject this SSE event sync object. So that is basically the connection that we are injecting. And then this is a standard JAX-RS server endpoint. So it's exposed, well, it will use the get method, the path is SSE, and it will produce that specific media type, which is specific to SSE. So it's all it takes to do that, to basically have an SSE endpoint. Obviously, in your SSE endpoint, so you just have the connection, so that means that at some point in time, you will have to push payload to a connected client. And for that, we are using the event sync object, so basically the connection object. We are using on that object the same method, and we just have to pass it some payload. You will notice that in this case, I'm using a shortcut. So I have also injected that SSE object, so it's basically a shortcut to quickly create SSE payload. You can do that multiple times, and obviously at some point in time, you will have to close the connection. So that is basically how SSE works on the server side. So you can use that, so JAX-RS SSE support with JavaScript clients, but obviously we have also added SSE support on the Java JAX-RS API. So it works like this. So we have SSE event source, which represents the connection, but now this is the client-side view of the connection. So that means that we have to establish the connection because SSE is always initiated from the client side. So we are using the standard JAX-RS client container for that. We specify the web target, so that is basically the URL of our remote endpoint. We then have the ability to configure a few things, like in this case, the client container will try to reestablish the connection every 5 seconds if the connection has been dropped. And obviously, at the end, you need to actually build that object. So that basically means building the SSE event source. Then what you need to do, you need to specify a few callbacks. One that you will have to specify is the one that will consume inbound SSE event type. So that is basically a consumer that will be invoked each time there is some payload that is being pushed on that connection by the server. You have the ability to register multiple callbacks. So you can have a consumer for inbound SSE event. You can have another one that will consume throwable type. That one will be invoked if something goes wrong. And I think there are 3 or 4 different types of consumer that you can have. And last but not least, once you are done, you need to invoke the open method. So that's basically where you tell the client container that it has to establish the connection, it has to register the different callbacks, and so on. And as soon as you open the connection, basically at any time the server will push through SSE some payload, your consumer will be automatically invoked. And again, at some point in time, you need to make sure that you close the connection on the client side. So, SSE support, these new reactive client API are basically the two new big capabilities that are added to JAX-RS 2.1. So it's not really a major update. Nevertheless, I think that those features are quite interesting, especially the reactive invoker. For example, on the server side, so in JAX-RS 2, you can have asynchronous request processing. To do that, basically, you had to inject an async response object. Now, there is an easier way to deal with that. So you have basically a JAX-RS resource method, and just to specify to the server-side JAX-RS container that the request processing has to be done in an async fashion, you just need to return a completion stage instance. Those kind of things. So something that I need to mention, JAX-RS 2.1 obviously is supporting JSON-B, which has been added to Java 8, and it also supports JSON-P 1.1. So I will talk now about JSON-P 1.1 and JSON-B. So in Java 8, we're improving the JSON support. So JSON-P has been moved to 1.0 to 1.1. So I will cover some of the update that has been done. And we are also adding a new binding API, that is the JSON-B API. So JSON-P 1.1 is basically about adopting new specifications that are emerging in the JSON space. It's JSON pointer, JSON patch, and JSON merge patch. So the first one, JSON pointer, is basically a syntax that you can use to easily reference a location within a JSON document. So it's basically some kind of regular expression, standardized syntax that you can use to basically point within a specific JSON document. So if we look at how it works, so I have a contact JSON-P object whose representation is on the right side. So to use the JSON-P API, I just basically need to create a pointer. So in this case, my location is /0/name, so that basically means the first object, so index is 0, and then in that object I want the key value whose key is name. So in this case, we are talking about Duke. So now I have my pointer, so that means that I need to do something with it. In this case, I will just, for example, get the value of that location. So what I will get in return is Duke. So get value is one of the methods that is supported by JSON pointer, but we also have an add, replace, and remove. So basically some very basic CRUD operation. This is an example of JSON pointer, but this time we are using the replace method. So obviously, given that it's a replace, we have to specify what the new value should be. And something important to keep in mind is that the JSON-P API is an immutable API. So that means that when we are doing a replace operation, what we get in return is a new object. We are not touching the original object. So moving on, another standard that is now part of JSON-P 1.1 is JSON patch. Again, a very obvious name. A patch is basically something that we use to modify a JSON document. The patch in itself is a JSON document. So the idea is that we have a JSON document with one or multiple operations that will be applied to another JSON document to transform that target JSON document. So let's look at an example. So this is a patch. This patch has two operations. The patch is atomic, so if one of the operations fails, the complete patch is aborted. So if we want to apply that patch to that target, so basically we go in a serial fashion. So the first operation is a replace operation. It uses the JSON pointer syntax, so /0 phone mobile basically means the first mobile phone. So the operation works, so that means that we can move on to the next operation, which is a remove operation. So it works, so this is basically the end result. So this is basically how a JSON patch works. Now if we look on the Java side of the story, we need a target to apply the patch. So the target is just a JSON document. Then we need a patch. A patch is also a JSON document. So we have a JSON document, and from that JSON document, we just create a patch. That's all it takes. Then we just need to apply the patch to a specific, to our target. And again, it's an immutable API, so the result object is a new object that has been created. So the JSON patch API is fairly easy to use, but it also has this nice builder pattern. So it's basically a front API that you can use to dynamically construct on the fly your patch. So in this case, we first have an add operation, then a remove operation, and obviously at the end we have to apply the patch. So it's something that is quite handy. So there's JSON patch, and there's also JSON merge patch, which is very similar to JSON patch, so I will not talk about merge patch. But something which is quite handy too in JSON P11 is that we have the patch operation that can modify the document, but we also have a diff operation. So basically it's the reverse operation. We have two documents, and we want to get a diff, basically the difference between those two documents. And it works for JSON merge patch and JSON merge patch and JSON patch. So that's something that is in JSON P11. Something that we also did in JSON P11. So this is not JSON P11. This is JSON P1.0 code. So we are basically using the stream API of Delabassee 8. And you see that at the end, my terminal operation, my collectors, I basically have to construct, I have to specify my own collectors. Why? Because JSON P1.0 doesn't have the notion of collector. It doesn't have any specific JSON collector. This has been solved in JSON P11. We now have specific JSON collectors. So it simplifies the code when you are using the JSON P API along with the stream API of Delabassee 8. Moving on the JSON front, we are adding a brand new API. It's time. It's basically a binding API. So that JSON-B API is to JSON what JAX-B is to XML. So it's basically an API that you can use to marshal and unmarshal Java object to and from JSON document. So it's a standard API, and the goal of that API is really to try to define a standard and very common behavior. But obviously, you as a developer have the ability to override that common behavior if that doesn't fill your needs. So a quick example, so we have a Java object. So we have a list of phones. So if we want to transform that Java object to a JSON document, well, we first need to have a JSON-B instance object. So JSON builder create. Again, I haven't specified anything, so that means that I will get the default behavior. And then it's just a matter of invoking the toJSON method on that object. And we pass it the Java object. And what we get in return is a string whose JSON representation would be like that. We could do the reverse operation. So in this case, what we get in return is a string type, but the JSON-B API also supports output stream, writers, and so on. And so you see that I haven't specified anything, so that means that basically I get the default behavior. So for example, the key names are basically derived from the setter name. So I have a set brand name, so that means that my key is brand. I have a set model setter, so my key name is model, and so on and so on. But obviously, you have the ability to override that. So the JSON-B API is introducing, I think, two new annotations to override that default behavior. So in this case, by default, our key name would be first name, but using this JSON-B property, we can specify what we want to get. And in this case, we want our key to be name. You can apply the annotation at different levels, so that's something that is part of JSON B11. And there are really a lot of ways to configure the JSON-B behavior. So, for example, what should you do when you have binary object, when you have blobs? What should you do with dates? What should you do? Well, you can tweak the orders, for example, of the key values, those kind of things. There are really a lot of possibility to basically override the default behavior or customize the default behavior of JSON-B 1.0. And if that's not enough, we also have support for adapters, like we have in JAX-B. So to configure and customize the behavior of JSON-B, it works like this. So we need a JSON-B instance, and we also have this new type, this new JSON-B config object that we will basically use to specify what behavior we want to get from JSON-B. And then when we create our JSON-B instance, we just have to pass it that JSON-B config object to get the behavior that we want to obtain. Now, something that I didn't mention, and this is really I think the most important thing about that API is that if you look around, there are already a lot of JSON binding solutions. There are already a lot of frameworks that basically do that. So we don't want to reinvent the wheel and provide yet a new framework to do binding between Java and JSON. So the JSON-B API is really a standard API that sits on top of different JSON-B frameworks. And you as developers have the ability to switch between the different JSON-B implementation. To do that, you just specify which implementation you want to use when you are creating your JSON-B object. So this is really the key aspect of that API. It's just a standard API. We will provide a reference implementation, which is based on, which is called JSON. But at the end of the day, you will have the ability to use a different solution if you want to. Now let's move on to the web front. In Java 8, we're updating the Servlet API. So in Java 8, we will have Servlet 4. Bunch of small enhancements in Servlet 4, but the key feature of Servlet 4 is really to bring HTTP2 to the Java platform. And we are talking about server-side HTTP2 support. So if you want to learn more about HTTP2, you should go to the other room right now. So I will give you a 1-minute overview of HTTP2. So HTTP2 is basically about reducing the latency of web application. And this is mostly achieved by switching from a text-based protocol to a binary-based approach. So HTTP 1.1 is a text-based protocol. In HTTP 1.1, if you need to fetch multiple resources to render a web page, basically your client will have to open multiple TCP sockets to do that, which is very expensive, both on the client side and on the server side. In HTTP 2, we have a binary protocol, so that means that to fetch multiple resources, the client will establish one physical connection, and on that physical connection, we have what we call streams, which are basically logical connections. So that means that we can, in a concurrent fashion, fetch a bunch of resources over one physical connection. So to illustrate that, I have a quick demo. So I have Glassfish 5. Yes, that is Glassfish 5. So the thing is that I don't have Mirror on my laptop, so it's a bit tricky. So I have Glassfish 5. So it's the yesterday build with one very basic application. So that application is, we don't see it here, doesn't matter. So this is basically what my application is. It just do one thing. It displays a picture. But if you look, that picture is in fact a matrix of pictures. So if I click here, this is the kind of picture that are downloaded. So there are 400 pictures. So to render that big picture, the server needs to fetch 400 pictures from the server side. So if I can, so the thing is that everything is local. So now I will basically go over the network, and not only that, I will also go via a proxy that will slow down my connection to really highlight the benefit of HTTP2. Demo Delabassee.com. Demo. To what? Yeah. That was on purpose to check if you. So. This is super slow. Why? Because I'm going through a proxy that basically slows down my connection. And this is over HTTP 1.1, 10 seconds, to fetch those 400 resources. Now I will do the same, but I will go, so I will use the same super slow proxy. GPS. And give them the it's HTTPS, it's 81. I will just make sure that I don't use the cache. I said don't use the cache. Okay. So it goes through the proxy. So we went from 10 seconds over HTTP 1.1 to, let's say, 4 seconds over HTTP 2. So it's really faster. And not only that, HTTP 1.1 was in clear. HTTP 2 is over TLS, if you can spot it here. So not only is faster, but also we are doing that over a secure connection, which is by definition more expensive. So this is basically what HTTP 2 is about, reduce the latency of web application. And this is part of a Java 8. And to basically convert my, so to add support for HTTP 2 to my very basic application, all I had to do was to deploy it on a Servlet 4 container. I didn't have to change the code to do that. So that means that you take an existing servlet today, you just deploy it over a Servlet 4 container, you will have HTTP 2 support out of the box. So you don't have to change your code unless you want to use one specific feature of HTTP 2, which is called server push. So server push is basically about giving the ability to HTTP 2 server to proactively push resources to the client. So with HTTP 1.1, the client do a request, the server will answer with one response. With HTTP 2, the client do a request, the server will answer with one or multiple responses. Typical scenario is that client asks for an HTML page, the server will get that request, and the server knows that to render that page, the client will need a picture, will need a style sheet, and so on. So the server can decide to proactively push those resources to the client. So if you want to use that feature in your servlet application, you will have to change your application a little bit. So there should always be an incoming request. So server push is not about giving the ability to a server to push resources in a completely asynchronous fashion. There should always be an incoming request, and then the server can decide to answer with one or multiple response. So we have the incoming request. Then, sorry, we have the ability to basically set the header of the response that will be used to push the resources. Then we need to specify the path on the server of the resources that we're about to push. And then, using the builder, we will actually invoke the push method. So it basically just to tell to my servlet container that I want that specific resource to be proactively pushed to the client. Now, it doesn't mean that because we're asking the resource to be pushed, that it will be effectively pushed to the client. There is no way to know if it has been effectively pushed. So we shouldn't assume that the resource is now on the client side. Because, for example, the client can say it's already in my cache, so I will just decline that push resources. Nevertheless, that is part of HTTP 2, Servlet 4. So you see that switching from Servlet 3.1 to Servlet 4 is easy. The only thing is that if you want to use server push, you will have to update a little bit your application. On the web front, we are also updating Java server faces. So in Java 8, we will have JSF 2.3. JSF 2.3 basically provides a lot of nice features if you are Java server faces users. For example, something that is part of JSF 2.3 is a server push, so HTTP 2 server push. So you take your JSF application, you deploy it on a Servlet 4 container, and if the clients happen to be HTTP 2 capable, you will use HTTP 2, and your JSF application will automatically try to push all its resources to the client. So a lot of nice features, support for WebSocket, for example. So we have a JSF WebSocket component that you can use to push payload from the server to the client without having to deal with the WebSocket API, those kind of things. So let's move on to CDI 2.0. And I believe there is a nice session on CDI 2.0 this afternoon. So, and Antoine is giving some prize to. So the main aspect of CDI 2 is not that important for us Java EE. So if you look at CDI 2, I think the main goal of CDI 2 is to boost the adoption of CDI outside of the Java EE ecosystem. The thing is that CDI is a quite rich specification. So that means that the implementation is relatively heavy. So when it comes to pure Java SE application, if you want to use CDI before CDI 2, you basically had to take everything. And in some cases, the CDI implementation alone was bigger than the pure application that was consuming CDI. So the goal of CDI2 is really to solve that. So the specification has been split in three. So CDI core, CDI, based on that, CDI for Java-SE, and then based on that, CDI for Java-E. That's what we consume on the Java-E side. We consume everything. We consume all of CDI. CDI2 also define how you can bootstrap in a standard fashion a CDI container in a pure Java-SE environment. Again, that's something that is not really important for us because, I mean, on the Java-E side, everything is handled for us by the Java container. Yes? Yeah. Yeah, that's a good remark. If you look at Java-E, we have a lot of API, lot of Java-E API like GPA, JAX-RS, and so on, which are defined for Java-E, but they are defined to work on top of Java-SE. So now CDI, that CDI has also been defined to work on top of Java-SE. We can see better. I'll say that. We can have other Java-E/Java-SE API leveraging those capabilities. Given that they don't have to assume that a full Java container is required to do that. So nevertheless, so CDI2, the big focus is really about that. So, but it doesn't mean that CDI2 doesn't bring new features for Java-E developers. So this is not new. So since the beginning, since CDI 1.0, we have a nice event mechanism. So it works like this. So you basically inject an event of a given type, and then if you want to fire an event, you just take that event type, and you invoke the fire event, the fire method on that, and you have obviously the ability to attach some payload. And then on the consuming side, you just need to have a method that is annotated with this @observe annotation to basically specify that this method has to be invoked whenever an event is fired. So this is something that is part of CDI 1.0. You can have one or multiple observers. The thing is that if you have multiple observers, it was up to the implementation, so it was up to the CDI implementation to basically define the order in which they will be invoked. So it was left to the implementation to do that, which might be tricky in some cases. So now you basically in CDI 2.0 have the ability to define in which order your observer has to be invoked. The thing that is important is that the lower the priority number, the higher the actual priority is. So that, yeah, it takes a bit of time to get used to that, but it's easy. I mean, 10 will be invoked before 20. It's an order, yeah, but the annotation is called priority. So, yeah, and JAX-RS is also using now the priority order, the priority annotation. Yeah, so it's really about priority, about observer ordering using the priority annotation. But once you know the trick, it's easy. So something else which is part of CDI2, and I think this is really, well, for me it's really the thing that is this is the nicest improvements of CDI. So if we look at the previous example, they were synchronous. So that means that they were basically everything was done in the calling thread. So the consumer and the observer. But now in CDI2 we have support for asynchronous event. So it works exactly the same way. The only difference is that this time we are using this new fire async method to basically specify that this method should be fired in an asynchronous fashion. And on the consuming side, we have this new annotation @observed_async to specify to the CDI container that this is an asynchronous observer. And I believe that we cannot mix sync and async observer, right? Okay, that has been removed, no? Because at some point there was discussion that, okay. So this is just an async observer, and that means that it can't be a synchronous observer. Okay, cool. So this is CDI 2.0. This is one of the two specifications that is led by Red Hat, and Antoine is doing a session this afternoon. Another specification which is led by Red Hat is bin validation 2. Gunnar did a session yesterday on that. So basically, bin validation 2 is basically about adding support for Java EC8. So being able to do validation using the new data type API, having the ability to repeat constraint validation using the repeatable annotation of EC8. Having the ability to apply constraint on all the elements of a container, those kind of things. So those are part of bin validation 2, and then the EG is also working on adding support for new constraint. Not empty, not blank, email, positive, positive or 0, negative, and negative or 0. That's it? Yeah. And for example, so they had some interesting discussion, like positive. So when you have 0, is that, and you are applying a positive validation, does that work or does that fail? So the end result is basically you have two annotation, right? So that means that if you have a 0 with just positive, it will fail? Okay. Okay. Okay, so very quickly, the last API that I want to talk about, again, there was a full session on that yesterday with Rudy. It's the security API for Java EE, JSR 375. So first, a disclaimer. So it's a security API for Java EE. It doesn't mean that before that API, Java EE wasn't secure. The thing is that Java EE was secure, but sometimes it was a bit tricky to secure your application. For example, you had to sometimes use JAX-RS, or you had to rely on container-specific capabilities. So this is basically what this API is trying to solve, basically simplifying the way you can apply security constraint within your application. So for example, they are adding the notion of an identity store. So until now, the way to deal with users, you had to rely on something which was application server specific. Now we have this abstraction identity store that allows you to basically have a standard concept that is portable across different application servers. We have a new authentication mechanism that is based on JAX-RS, and that is way simpler to use than having to deal with the JSPIC API. So this is basically what that expert group is working on, trying to simplify how we can easily apply security concern in a Java EE application. So, wrap up. Java EE 8. It's really about simplification of the platform, and we're also putting a bit of modernization. So for example, we are adding a JSON Binding API. We're adding support for new standard in the JSON space. We're adding support for HTTP2, and so on and so on. So this slide basically shows in blue the API that are updated in Java EE 8. We went through all of them. And in orange at the bottom, those are two brand new API that we're adding to the platform. What is not on my slide is the specification that will be updated to what we call a maintenance release. So a maintenance release is a lightweight process to basically do a more simple update to a specification. So for example, we can mention GPA. So GPA will be updated. The interceptor spec of EGB is being updated through an MR, and so on. So if we look at where we are, all the specs, but the security have gone through the public review. So basically that means that we are in very good shape. The security spec is right now in public review. The thing is that they have to go through a ballot. I think at the end of the month, they will have to go through a ballot. Then the next step is really to go through the proposed final draft. And so bin validation is moving towards that, JAX-RS is also moving towards that, and so on. And once that will be done, we will be able to finalize the Java EE umbrella specification itself. So the idea is that we would like to wrap up that during the summer. We say that it would be July. It might be a little bit, well, it might be more towards August, but in the summer, you can be sure that Java 8 will be finalized. That means that shortly after that, we will have the final version of Glassfish 5, which is the open source Java 8 reference implementation. But already today, you can grab bits of Glassfish 5 and start to play with the different specifications that will be part of the Java 8 platform. Something that I need to mention is that we have recently moved all the Java development and the Glassfish development to GitHub. So no more Java.NET for us. Yes? So just go on github.com. We have a Java organization that basically groups most of the Java project. For example, JAX-RS and Jersey were already on GitHub, so we decided to keep them outside of the Java organization from now. But nevertheless, this is the place you need to go. We have also moved all the discussions related to Java EE to groups.io. So we now have finally a modern platform where we can discuss the Java EE platform. Also, our goal is to put Glassfish Docker image so that you can easily use Glassfish. Those images will be on Docker Hub. We already have a few, and that's something that we're working on. So the last thing is that I have 1 or 2 minutes. So you can help us contribute. So we have this Adopt a GSR program where we basically ask JAX to pick up a GSR and provide feedback. Now we are getting late in the cycle, so feedback. If you have to feedback, please do it quickly, because as you saw, we are wrapping up the different specifications. But nevertheless, you can still contribute. So you take, for example, a GSR, a specification, and you write samples. You write examples on how to use that GSR, how to use that specification, or you write small application that combines the different API of the Java EE platform. Those kind of things are very useful for the community. So with that, I have, what, 2 minutes? 1 minute? I have 1 minute for questions or remarks. So is there any questions? Summer. No, we don't have an exact date. But I will give you a hint. So there's the summer, and then there is a small event in San Francisco, which is called Java 1. So that's between the two. Yes? That's so last year at Java 1, we've basically laid out a plan for Java 8 and Java 9. The feedback that we had is that it was not realistic to work on the two at the same time. So we decided to focus on Java 8. Once we will be done, we will basically go over what's next. So you can expect to have news on that, or again, at Java 1, I think that it's pretty safe to have a better view on our ID for the future. Yes, yes. We don't see them. Java 8 is based on AC8. So having said that, obviously we are in the same organization as the Java IC team, so we are discussing with them. So, but right now for us, on the Java side, the modules, it's more, well, I will not say it's a wait and see, but we'll have to really think about what the modules means to Java EE when we will be based on AC9.